Cryptographic algorithm for enhancing data security, a theoretical approach. Abstract, the quick progress of this technology becomes vital in upcoming years. Any type of data present in cloud is confidential for individual, and this can be hacked by attackers while sharing it with the intended recipient. The demand for veracity, privacy, fortification, solitude, and procedures required for handling is increased. This paper discussed brief about cryptographic methods and a new cryptographic algorithm method for securing the data for enhancing data security that can be used to secure applications on cloud computing. Keywords: cryptography, symmetric key, twos complement, encryption, data security, encryption, decryption. Introduction. The Greek meaning of cryptography is secret writing. Data security is one of the major concerns in today's world. Cryptography is a method to fulfill the confidentiality of data. Cryptography provides the privacy of data for an individual or organization by converting the original data to a readable, ununderstandable format for an unauthorized person and converting back to original data for the authorized individual one. Cryptography technique translates the plain text to another format, which is called ciphertext with an encryption key, and can also convert ciphertext back to plain text with the same or different encryption key based on the technique used to encrypt the data. Characteristics of cryptography. Data security secures the plain text. Data breaches protects from the release of confidential information to the environment. Authentication and authorization allow only the authentic individual to read/write the data. Types of cryptography. Cryptography is a method that is linked to convert plain text into ciphertext I.E called encryption and convert back to plain text I.E known as decryption. Various types of encryption and decryption are available, but the most commonly used algorithms for cryptography are Symmetric Key Cryptography. In this cryptographic approach, a single key is used to encrypt and decrypt the data. The key must be known to both the clients to read/write the data. There are different methods of symmetric key algorithm like DE, 3DES, EASE, and more. Asymmetric Key Cryptography. In this cryptography approach, there are two different keys to encrypt and decrypt the data. The key used to encrypt the data is called public key, and the second key is used to decrypt the data called the private key. Both keys are different from each other. Private key is only available to the receiver. Literature review. Ryamagupta proposed efficient encryption techniques in cryptography, better security enhancement. The paper promotes the encryption technique and reviewed their restrictions and approach. Also, talked about the transpositional approach like simple columnar, simple row, root cipher transposition too. Aoshi proposed a symmetric key cryptographic algorithm. She had introduced two primary types of cryptography, symmetric key and asymmetric key technique. She also proposed a fast symmetric cryptography algorithm. She used keys as greater or equal to 1000 and converted the plain text to ciphertext using some binary and mathematical calculations. 3. Ekta Agarwal et al. Had proposed a secure and fast approach for encryption and decryption of message communication. The authors had discussed cryptography architecture, performance, and more. They had compared the symmetric technique of Aoshi 3 with their proposed algorithm and found their algorithm much faster. 4. Abhishek Joshi and their co-author proposed an efficient cryptographic scheme for text message protection against brute force and cryptanalytic attacks. The paper describes the cryptographic scheme and protection from brute force attacks. The author shows that this technique can be used for significant applications. 5. Suyash Verma et al. Proposed an efficient developed new symmetric key cryptography algorithm for information security. The proposed new block cipher technique is faster than the existing mechanism. They concluded the result by calculating with different plain text in the same key, DPSK, mode 6. Dr. Purna Mahajan et al. Proposed a study of encryption algorithm EASE, DE, and RSA for security. Authors reviewed three encryption techniques like EASE, DE, and RSA, mentioned the comparison results of the effectiveness of each algorithm. 7. Symmetric approach. Symmetric key encryption takes less execution time and is always easy to implement in real-life applications, yet their drawback is that both clients need to move their keys. Security 8. This approach highlights improving the standard method of encryption by using the substitution technique for. In this proposed algorithm, the first single character is converted into its respective ASCII code value, and further encryption continues. Proposed Symmetric Key Algorithm. Encryption Algorithm. Step 1. Convert a single character to its ASCII value. Step 2. Add a key as 100, add it to the character's ASCII value and store it in a variable. Step 3. Generate the binary value from the variable got in Step 2. Step 4. Make the binary number of 8 digits by adding 0 on the number's left side. Step 5. Reverse the binary got from Step 4. Step 6. Split binary numbers in two equal parts as element 1 and element 2. Step 7. Find the 2's complement for both equal parts and store them in complement element 1 and complement element 2, respectively. Step 8. Concatenate complement element 2 with complement element 1. Step 9. Find the 2's complement of the binary got in Step 8. Step 10. Generate the hexadecimal value of the binary got in Step 9. Step 11. Formate the hexadecimal value got from Step 10 to have a minimum of 8 digit if already the code is not of a minimum of 8 digit, and return that as a ciphertext. Example. Let us take a single character, C. Now, we will get the following steps according to my proposed algorithm. Step 1. ASCII of C is 67. Step 2. Adding 100 as a key to ASCII of C in S1 equals 100 plus 67 equals 167. Step 3, now we got the binary of 167 as 10100111. Step 4, binary in Step 3 is already of 8 digits. To continue with binary we have in Step 3 as 10100111. Step 5, now, the reverse of the binary we have in Step 4 will be 11100101. Step 6, now, we have to split the binary from Step 5 into equal halves as element 1, 1110 and element 2, 0101. Step 7, now, 2's complement of each element got in Step 6 respectively will be complement element 1, 0010 and complement element 2, 1011. Step 8, next, we have to concatenate complement element 2 with complement element 1, that will be 10110010. Step 9, further, 2's complement of binary got in Step 8 will be 01001110. Step 10, finally, the binary received from Step 9 in hexadecimal will be F4696. Step 11, formatting the hexadecimal code got from Step 10 to a minimum of 8 digit as 000 F4696. Figure 5 shows the architecture of the proposed encryption algorithm. Decryption algorithm. Step 1, convert ciphertext to binary. Step 2, format the binary to 8 digits by adding 0 on the left side of the binary is not already formatted. Step 3, find 2's complement of the binary got in Step 1. Step 4, split the binary got in Step 2 into 2 halves as element 1 and element 2. Step 5, find the 2's complement for both equal parts and store them in complement element 1 and complement element 2, respectively. Step 6, concatenate complement element 2 with complement element 1. Step 7, reverse the binary got from Step 5. Step 8, find the ASCII value of the binary got from Step 6. Step 9, subtract the key 100 from the ASCII got in Step 7. Step 10, convert and return the ASCII value from Step 8 to its respective character value as single character. Example. Now, let us take ciphertext as 000 F4696. Now according to the proposed decryption algorithm, we will get the following steps. Step 1, converting ciphertext to binary, we would get 1001110. Step 2, after formatting binary number from Step 1 to 8 digit, we will get 01001110. Step 3, 2's complement of binary got in Step 2 will be 10110010. Step 4, now, we have to split the binary from step 4 into equal halves as element 1, 1011 and element 2, 0010. Step 5, now, 2's complement of each element got in step 4 respectively will be complement element 1, 0101 and complement element 2, 1110. Step 6, next, we have to concatenate complement element 2 with complement element 1 that will be 11100101. Step 7, now, the reverse of the binary we have in step 6 will be 10100111. Step 8, ASCII of the binary got from step 7 will be 167. Step 9, after subtracting the key, 100, from the value received in step 8, we get 67, 167 to 100. Step 10, the character value of the ASCII we get from step 9 will be C, which is the plain text. Experimental analysis. For experimental analysis, the proposed algorithm with the symmetric key is coded in Python 3.8.5. The i7 preprocessor, 2.6 GHz Intel processor with 12 MB cache memory, and 8 GB RAM, DDR4 2933 MHz. A single character show encrypted and decrypted in shown figures. Conclusion. Cryptography is transforming plain text to non-understandable readable text to protect private data. 910. We have to exchange multiple types of data on the internet that can be confidential. Cryptography is used to hide the original data, i.e., plain text, from unauthorized access by converting it to an ununderstandable format by some mathematical combination. 10.8. This paper has introduced a new efficient algorithm of cryptography that is very simple to nature with the least execution time for encryption and decryption. Also, the proposed algorithm is easy to apply in a real-life project for the encryption and decryption process.